Hi, in today's video we're going to take a look at functional groups. So what exactly is a functional group? It can often be abbreviated as an FG. Well, the basic definition of a functional group is a collection of atoms with similar reactivity and similar physical properties. Now, to talk about these generic functional groups, I'm going to use sort of a convention that we often use in organic chemistry. I'm going to look at a particular functional group. Let's look at this one. Okay, so this R, what is this R and then OH? Well, R is just a sort of generic placeholder. Okay, and we call this a generic alkyl group. So R could be a methyl, ethyl, propyl, cyclohexyl, whatever. So it's just some carbon-based compound that's now attached to something like this. Now, this is a functional group, so I'll put a sort of dashed line around this. This is called an alcohol functional group. Okay, so if I had a methyl group here, this would be methanol. If I had an ethanol, that would have an ethyl group. That's everyone's favorite compound. Maybe you had that this past Friday, who knows? Ethanol, propanol, etc. But this group now is classified as a functional group. So ROH would be an alcohol. It's also sometimes called a hydroxyl group. Okay, so that's a basic example of what a functional group would look like. Regardless of what the R group is, this would still be called an alcohol, and it's going to have similar reactivity and often will have very similar physical properties because of the collection of this oxygen attached to a hydrogen. So let's just list out on the side here what are some of the main functional groups that we will be covering and that you'll need to know about. All right, so first, we're going to just start out with the hydrocarbons. Okay, so here we have a saturated hydrocarbon. This is called an alkane. Carbon-carbon double bonds, an alkene. And then we have a carbon-carbon triple bond, which is called an alkyne. Now, the reactivity of an alkane is very different than an alkene, which is even different from an alkyne. Now, just for a little bit of help here, you'll also be able to see that not only can you look at the functional group, but let's also just put in here nomenclature issues. So what's the suffix that these would have? Well, we know that for all of these, the suffix would be ane, ene, or yne when you're trying to name these various compounds. So an alkane always has the suffix ane, an alkyne has ene, and so on. So those are some basic ones that we've already talked about in terms of structure building and nomenclature. But let's look at some others that have now other atoms. Let's add the alcohol to our group. Okay, so here's an example where I have an OH group. And the suffix that we use when we name alcohols is OL. So for example, ethanol or methanol. Now this, we'll find out later that the OH could potentially be on a carbon that has only one hydrogen, two hydrogens, or three hydrogens. So we'll get to that a little bit later. We can classify alcohols based on the number of carbons coming off. Another example is related to the alcohol. Instead of having an OH, it has an SH group. This is called a thiol. And it usually has the word thiol in the name. Another one that has oxygen, whoops, is going to just have an oxygen now attached to another carbon-based group. This is called an ether. Okay, so ether is actually in the suffix, or it's actually used in the name for those as well. We also could have some double bond oxygen compounds. Okay, this first one here has a C double bond O attached to a hydrogen. This is called an aldehyde. And it usually has the suffix Al. This one that has a C double bond O, but it's attached to 2 carbon groups, is called a ketone. And that usually has the suffix -one, O-N-E. Some other derivatives or things similar to this, we could have this group. This is a very important one in organic chemistry. This is called a carboxylic acid. And the suffix that we use for that is OIC, acid. So you can see we're starting to build up quite a bit of structural complexity when we start looking at a variety of different functional groups. There's a couple others I'd just like to kind of I'll put them right here so you'll have them in your notes. Another one that we definitely will be talking about quite a bit is this one. It's called an ester. And it usually has the suffix -08. Let's see, one that's now going to be quite a bit different than any of these. We're going to put a nitrogen in. This is called an amine. And in the name, usually the word amine is there. And then lastly, I'll just write the last one. It's kind of related to an ester and an amine, but now instead of having an oxygen next to a double bond oxygen, we're going to have this. So this would be called an amide functional group. And it usually has the word that came off usually has the word amide in the name. And just one thing on the word amide, depending on whether you're in the United States or in England, you might say it amide. That's typically if you're from England. Most everyone else says amide. All right, so that's just kind of a brief review of the main functional groups that we'll be talking about in our class. And you definitely, at the very beginning of working on this stuff and working through homework problems, you want to be able to identify the types of functional groups that might be in a molecule. We'll take a look at that in our next example. All right, let's take a look at an example of a molecule that has several different functional groups and see if we can get a little practice at identifying some of these. Let me draw this out first. Okay, so here's a fairly simple organic molecule, but notice it's got quite a bit of structural complexity going on. So let's identify the main functional groups. So here we have a C-C double bond. So let's just put sort of a dotted line around that. And we know that this now represents an unsaturation. Carbon-carbon double bonds are called alkenes. So this would be called an alkene functional group. And notice that collection of atoms is different than other parts of this ring that are saturated. They don't have a double bond. Another functional group is this one here. When we looked at it earlier, this is an alcohol, an OH group. Next, we have this group. So it's a C double bond O, but notice it's now connected to a carbon on this side and a carbon on this side. So this is called a ketone. And then lastly, we have an NH2, or a nitrogen-containing group attached to one carbon. This is called an amine. So in just a very simple molecule, not that big, we actually have 4 different functional groups. So you might be asking, well, why is this important to me? You know, why do I need to know about functional groups? Well, functional groups, as I mentioned, they have different reactivity. So certain parts of the molecule are going to be able to either undergo a reaction, or be differentiated between certain sides. So this amine group has some very specific reactions that only amines can do. Alcohols, ketones, and alkenes can't undergo those same type of reactions. So when we start getting into things, related to health and medicine, this different reactivity often leads to different binding. So different binding, if I could spell right today. Sorry about that, guys. Or affinity. when it comes to binding, say, enzymes or receptors. So many drug molecules contain multiple different functional groups, and it's the certain collection of those functional groups and also the scaffolding provided by the carbon skeleton that gives a molecule its ability to do its function, whatever that might be. Lastly, the physical properties of this molecule are going to be dictated by the collection of functional groups. And when I say physical properties, I'm talking about things like solubility, melting point, boiling point. All of these are affected by what types of functional groups are collectively in a molecule, as well as the carbon skeleton. So this becomes really important when you start getting into looking at drug molecules. There's often a balance between solubility in drug formulation and lipophilicity, which is the amount of residence time that a drug might have in the body. So let's just look at one other drug example and see if we can, maybe identify what the functional groups are in this compound, which I'm sure you're all aware of, probably have taken this drug. Okay, so here is a molecule that you're all very familiar with. This is called aspirin. And it has some functional groups that we've just been talking about. So this one here that has a C double bond OOH, that's called a carboxylic acid. I'll just abbreviate it as carb acid. That functional group is very different than this one over here. This also has a C double bond O, but notice it's got an oxygen attached to some other carbon on this side, and then a carbon over here. This is called an ester. And then lastly, this actually can technically be classified as a functional group. I didn't put that on our list before, but this is actually an aromatic or benzene functional group. So we have basically 3 different functional groups in this molecule, and it's the specific collection of the functional groups and the carbon scaffolding provided by the benzene and the other carbons that give aspirin its actual physical properties and allow it to be an effective drug. All right, I hope this has helped in terms of summarizing the main functional groups. You definitely want to do some homework problems and getting some practice identifying different functional groups in a little bit more complex molecules.